right, as we get started today, we're going to go ahead and begin by finishing up that first set of ACT prep, doing numbers 10 through 12. 10 through 12, the third page of the handout that is in the description from a couple lessons ago. Take just 3 minutes to work these 3 problems, and you may begin.
What's an irrational number?
That's what you're expecting you to find out. We'll go over it when we go over the answer, though.
Try and find my homework.
Sure.
Okay.
About 30 seconds longer. Let's see how we did on these. Chris was first. Chris, number 10. How many irrational numbers are there between 1 and 6?
3.
No. Let's see. Didn't catch who was second, Quentin or Jamie. Jamie was second. Jamie, what did you have?
Okay.
Okay, there are infinitely many. What is an irrational number? That was the question Chris asked. Class, help us.
Like square root of something.
A number that doesn't repeat.
Square root of something.
Square root of something, right? So between 1 and 6, what are some values? Well, 1 is class the square root of 1, right? And 6 is the square root of 36. So we're thinking for irrational numbers in this gap. And you might say, well, it's not infinite, right? Square root of 2, square root of 3, square root of 4 is rational, square root of 5, square root of 6, square root of 7. But it's not infinite, right? Like there's a set number here, isn't there? No. What about the square root of 2.1? Square root of 2.2, square root of 2.2003. You get the idea? There's an infinite number of numbers you can make up. Strategy tip. If infinite is an answer or is an option, usually the answer. That's what I have.
That's what I was thinking. I was like, it has to be.
Yeah, if you're like infinitely many, that's just got my gut. Just got to be it. Most of the time, they don't throw that in there unless it actually needs to be the answer. Now, don't still take time to think through things, but that's just what I found with the ACT. All right, number 11. So we'll stay with Jamie. Typical high school student consumes 67.5 pounds of sugar per year. That's a lot. part of the new nutrition plan, each member of a track team plans to lower the sugar he or she consumes by at least 20% the coming year. Assuming each track member has consumed sugar at the level of a typical high school student and will adhere to this plan for the coming year, what is the maximum number of pounds of sugar to be consumed by each track team member in the coming year?
D.
D. A couple ways to find it. If you're reducing by 20%, what percent of sugar intake are the track team members going to still consume? 80. So you find 80% of the traditional 67.5 loaves. And so you multiply by 0.8 and you get your 54 pounds of sugar. Or you say, well, they're going to reduce by 20%, so find 20% of 67.5. And you end up getting 13.5. Well, that's what they're going to reduce, and then subtract the 13.5. Still get 54 pounds. Either way, you want to work it. Of course, you can do it on the calculator as opposed to on paper.
Forgot to minus 13.
Ah, gotcha.
So I just put 14 because it's wrong.
Ah, I see. All right, number 12. In the standard XY coordinate plane below, 3 of the vertices of the rectangle are shown. What's the 4th vertex of the rectangle, Jamie?
F.
It is F, 3, -7. And you know what? I don't think I have candy down here, but remind me in physics later. Yeah, I don't. Remind me in physics later, and we'll get you the candy. Anyone else have F for number 12? All right. Really with that, you kind of just sketch it out, right? That's literally what I did to solve it. I sketched it out to figure where the 3rd vertex was. There's math you could do, but a lot of times drawing pictures is easier. With graphing problems, I'm a big fan of pictures. Just a strategy tip. Questions on 12? All right, any questions on any of these? I set that aside. Keep that with the rest of your ACT prep. Tonight for homework, by the way, we're going to do some SAT prep over the weekend. So I'm going to mix it up, give you a little of both, so that way you can kind of compare the testing styles to each other. And that's coming up here in just a little bit. For now, let's review over the equations we've been using since we started talking about radian measure and things moving around in a circular pattern, walking around circles or running around circles or even spinning around circles. First equation was to find the length of an arc. Quentin.
So it's something equals.
Something. Yeah, it is something equals something. Jamie?
The R.
Ethan?
S equals R theta rad.
Yeah, S equals R theta rad. There's equation number 1 we need to have memorized. That scares me a little. All right, then we talked about the speed at which an object goes around in a circle, and we called that speed velocity, or more specifically linear velocity. And we have 2 equations for linear velocity. Give me at least one of them.
V equals R theta rad over 2.
And the other one?
V equals
What is R theta rad?
S. V equals S over T.
V equals S over T. So again, if you remember one of these 2, you should remember the other as long as you also know this one. And then we talked about not so much how fast is the object going around the circle, but how fast is the circle itself spinning. Not so much how far does it travel per unit time, but how much of an angle is rotated, or how much of an angle is accomplished per unit time. What do we call that? Back to Quentin. Not linear velocity, but angular velocity. We didn't use V, we actually used a Greek letter. It looks like a W, I don't remember what it actually is. Omega, good. Now capital omega, looks like this. You've probably seen that before, but the lowercase omega, it looks like kind of like the W. And what's our equation for omega, Quentin? There we go, theta rad over T. The angle that's accomplished, the amount of angular turn divided by time is the angular velocity. And if we kind of tie these 2 equations together, remembering that theta rad over T is omega, that gives us another equation for linear velocity, Ethan.
Is it D equals, or omega? I'm trying to figure
Chris,
out how
help
it
us?
starts.
Why am I forgetting what the thing was? V equals theta rad over W.
Jamie?
V equals R omega.
Good. Take the theta rad over t and put an omega in its place, because omega is the theta rad over t. So this all just becomes omega. V equals R omega. And so we technically have three different equations for linear velocity. So these are the equations that we needed to have memorized by today. All right, so let's take a look at your homework.
Wait, what?
Yeah, so let's take a look at the homework here. V equals R omega. Okay. And let's take a look at the homework, pages 47 to 49. You did numbers 22, 26, 28, 32, 38, 46, 52, 54, 60, and 64. Let's see how we did. Number 22, finding linear velocity given s and t. And let's start with Ethan. What was the linear velocity for an object that travels along an arc of 734 yards, I want to change that to feet, in 26 hours 11 minutes, which is a whole lot of seconds. Very slow.
0.023 feet per second.
There we go. I went with the third sig fig because I converted the 26 hours 11 minutes into a big number of seconds by definition. So I kind of went infinite significance there, but I can respect the two sig figs you went with as well. 0.023 or 0.0234 feet per second. Number 26, in 1.54 seconds, there's your time, an object moves through an angle of 126 degrees 56 minutes. Change that to radians. There's your theta rad. Once you do that, along a circle with a radius of 67.82 yards. Change that to feet. What is the linear velocity, Chris?
97.56.
That's yards per second. Multiply that by 3. So 97.56 yards per second.
92.66.
Good, and round it off. I'll go 3 sig figs from the 1.54 seconds. 293 feet per second. How many had those answers on those first two? They were pretty involved. Just forgot to multiply the 3.
No, I forgot that I didn't do the first one.
First one, do we need to see either of those worked?
First one.
All right, so we've got V equals S over T, which we have memorized, right? And we've got our 734 yards times 3 to get feet. And then we've got our time is 26 hours, 11 minutes. So we're going to multiply this by 60 to get seconds. We're going to multiply this by 3,600 to get seconds. And I'm going to add the seconds and seconds together. So I get the denominator first. 26 by 3,600 gives how many seconds? It's a whole bunch.
93600.
93,600, 93,600. All right, and then 11 times 60.
660.
660, and then add those together to get your total number of seconds.
Oh, 190,000. No, that's one wrong. 660. I times. Wait, yeah, 94,260.
All right, and then the 734 times 3.
2,202.
And then when we just divide, and that gives you your feet per second. Does anyone need to see number 26 worked out?
Yeah.
All right. Well, for starters, Ethan, you'll want to change your 126 degrees 56 minutes into radians. So multiply by pi over 180 degrees. Nice thing is, again, your calculator, you don't have to do the initial step of changing to decimal degrees. Not that it takes that long on the other calculator anyway.
Just type it in second function. Extra 3 keystrokes.
Yeah, when I do it, I get a bunch of weird stuff. I don't know what it's. Or do you want me to like do that and times pi divided by it? Because then just put the pi over it.
Let's try this. 126 degrees, 56 minutes, divided by 180 degrees. That's what I forgot to tell you. Divided by 180 degrees. That gives you the weird fraction, which you then multiply times pi. Where's pi?
At the bottom.
The bottom second, the shift function. All right, there you go. That's your angle in radians. It's like 2 point whatever. And then you put that in the memory. So there's your theta rad. So yeah, sorry, divided by 180 degrees. Not pi over 180, pi over 180 degrees. So I failed to specify that. And again, what I did, I divided the 180 degrees first. Then I multiplied the pi. I think that's probably going to be a more direct approach for you. The radius says 67.82 yards. We're going to multiply that by 3.
67.8.
67.82, which is in your book, right there in front of you, times 3.
It's 23.46.
And that's feet. and then the time is 1.54 seconds, which actually is what we want. So we're going to take r theta rad, then multiply memory times what's on your calculator now, get that product, and then divide by the 1.54, and it should give you about 293 feet per second. And y'all were good.
That's right, 1.3.
Right.
I got it.
All right. So again, the upside to you guys is by putting it in the decimal degrees, it takes care of the whole pi over 180 thing. There's not that little remembering the degree symbol necessarily. All right, number 28. Finding the time given S and V. Again, we're going to take this equation, V equals S over T, and we're going to alternate to find the time. So ends up being time is S over V, arc length divided by velocity. What do you get for the time on number 28, Quentin?
6.8 seconds.
6.8 seconds. Turn the page. Number 32, finding the time given r theta and V. Now looking at this equation, alternating r theta rad over V. So on number 32, we've got the r, we've got the theta rad, multiply all that out, then divide by the velocity, get what time there, Ethan?
I had 59.5.
I went 2 because 1.6 inches per second,
260.
so I went 59.
Oh, okay.
59
I
seconds.
just don't.
I had 59.3, so I'll probably.
Yeah, so rounded up, rounded
Yeah,
down
59.
to 59 seconds.
I had something after it.
All right.
I think it was.
Are we good on the 2832, the last two problems?
I have a question. That 59.3, would that just be small points off?
Yeah, just minus a point for sig figs. Yeah, good question. Let's see, number 38, finding the radius. Same equation, but now we're going to want to multiply by time and divide the theta rad to get r equals tv over theta rad. So on number 38, silence. And let's go vibrate. Forgot to do that this morning. All right, we now return to your regularly scheduled programming. So we're going to take the time, which needs to be converted to seconds. So 13 minutes times 60, what's that, 780? Plus 46 more seconds, which is like 826-ish seconds, something like that. Multiply that time times the theta, or times the velocity, 61.4 centimeters per second. That's okay. That just means our answer is going to be centimeters. And then we're going to divide by the theta rad, but it's not 30 degrees, class, it's pi over 6. And we do all of that, you end up getting how many
I
centimeters?
had 3.39.
Oh my.
970 meters after.
Okay, that's 970 meters would be acceptable, no problem with that. I left it in centimeters. I had 97,000 centimeters. Or I could make a case for the third sig fig there and go 96,700 centimeters or 96.7 or 967 meters.
That's one more digit you have to write.
I know. Do we need to see number 38 worked out?
Yes.
All right. So, again, did you get the correct equation? R equals TV over theta rad.
I'm not sure.
Okay, you got to show the work. Quizzes, tests, got to show the work. Now we get partial credit in case you bomb it. Okay, so R equals TV over theta rad. Again, the time you've got to change it to seconds. So this is 13 times the 60 plus 46. Do that quickly. 13 times 60 plus the 46.
254.
Only 254? 13 times 60.
I thought you said 16, my bad.
13 times 60 plus 46.
826.
I think I did have it right. 826 seconds. The velocity was spelled out for you, 61.4 centimeters per second. Now there's the seconds and the per seconds cancel. That's why I'm going to get centimeters for my answer unless you wanted to change it to meters. And then the theta rad said 30 degrees. We're going to divide that by pi over 6. Now, you're going to want to put parentheses around pi over 6 here. So 826 times the 61.4, divide by pi, but divide by parenthesis, pi divided by 6, close parenthesis.
96,861.
There it is. Yeah, does that make sense?
I never use the parentheses. I always just do it.
Well, if you do divided by pi divided by 6, you're going to end up doing it backwards.
Right, I do. So I do the pi divided by 6.
Oh, put that in the memory. That's fine as well. Pi divided by 6 in the memory first, and then divided by memory works great. Yep, 97,000-ish. All right, questions on that? Let's go to number 46 on the next page here. Finding angular velocity. What's our equation for angular velocity, class?
Omega equals theta rad.
Theta rad over t. So we've got our theta rad in 46. We've got our t. We just divide theta rad, divided by time. What do we get, Jamie?
0.23 seconds.
Not per second. There we go. 0.23 per second is correct, or radians per second if you must. Number 52, finding linear velocity given r and omega. Well, v equals r omega. And so we just multiply the r times the omega. And what do we get on number 52, Quentin? 34.7 times 0.85.
1054.3.
Oh my. Ethan.
29.
I got 29 feet per second. 29 feet per second. I'm not quite sure what happened over
I
there.
looked at the wrong problem.
Oh, okay, that would do it. All right, let's go back to Quentin for redemption on 54. We're finding angular velocity given the velocity and the linear velocity and the radius. So to get omega by itself, class, I need to divide out the r. So now I'm going to take v over r, which actually works fine on 54 that they're both millimeters because the millimeters cancel anyway. What do we get, Quentin? 1.3 per second, or radians per second if you must. Number 60, finding the angle of rotation. How do we represent angle of rotation, class? No, angle of rotation. Theta rad. Angle is theta. Theta is angle. Okay, rotation is angle. Angle is theta. Rotation is theta. Angular velocity is omega. But we're just finding theta here, given omega and t. Well, if you want theta, just multiply both sides by t, right? Get t omega. So we're just going to multiply the time times the angular velocity on 60. 29 seconds times the 12.5 radians per second. How many radians of rotation here do we get, Chris?
I used the wrong equation, but I'll tell you my answer anyways. I got 0.43.
Yeah.
43.1.
Oh my.
363.
363 radians, or just 363. And you don't use any unit at all because radians are unitless.
That's just multiplying.
Just multiply. You literally just plug in the numbers in on the calculator. So you say, but you have to have the formulas memorized. You must have the formulas memorized. Number 64. Finding time given omega and theta. Well, again, if omega equals theta rad over t, and we want time, alternate, right? Time is going to equal theta rad over omega. And so we just divide the theta rad. Thoughts, Jamie?
Convert to, or do you times the pi over 180?
Right. If you happen to have 3 pi over 4 memorized by some strange chance, you go with that. But multiply by pi over 180 to get your theta rad. Then divide out the omega to get
0.188 seconds.
0.188 seconds. Okay. Questions on that?
I somehow got that one right though. So I don't know if maybe I figured out that I had the wrong equation and went back to the right equation.
All right. Questions on this?
So you ever went to quiz today?
Let's take a look at number 66. Look at 66. And tells us to solve for what, class?
Angular velocity.
Angular velocity. And what numbers are they giving us here, Chris?
62, our radius equals 62 meters. S equals 254 meters.
What does S represent?
Velocity? No.
S. Arc length.
Arc length, yeah.
Arc length. So what was the number again?
254 meters, sorry.
254 meters, okay. And then the other number they gave you is?
Time.
Time is
11 seconds.
11 seconds. So all the units work out exactly like I want. And it says to find omega. What is my equation for omega, class?
Omega equals theta rad over t.
Theta rad over t. Problem is, I have t, I don't have theta rad. But I have S and R. Somehow S and R should allow me to find theta rad. What's the equation that involves S, R, and theta rad?
S equals R theta rad.
S equals R theta rad. So if I want theta rad, I would need to divide away the R. So if I just take S divided by R, that is theta rad. So at your seats, S divided by R.
4.96. 4.096.
All right, and then divide that by the time. And what do we get?
0.372434018.
How many sig figs?
2.
2. So we get?
You can argue 3.
0.37.
I can't argue 3. I can only go 2. So 0.37. And what is angular velocity?
Per second?
Per second. Rotation per time. So radians per second or just per second. Look at number 68. Same type of thing here. They give us a radius of
10.1.
10.1 inches. which my initial thought is, do I have to change that to feet? But no, the arc length is also given in inches.
343.
And the time?
3.4 seconds.
3.4 seconds. Again, to find omega, I need what equation?
Theta rad over t.
Theta rad over t. But to get theta rad, I'm going to need to say that theta rad equals
S equals theta rad.
S equals R theta rad. So theta rad equals
S over R.
S over R. So we're going to divide the S over R. That gives you theta rad, then divide by time.
9.98.
Good, or round it to
9.99.
2 sig figs.
10.
That's only
10 points.
10 point per second. Questions on that? Does that make sense? All right. I want you to do numbers 45 to 67, the odd. 45 to 67, the odd. What I'd like you to do, write the formulas as needed. Okay? You got to have them memorized anyway. As needed, write formulas. But the math itself isn't hard, right? The calculator does all the work. You just have to know where to put the numbers. And without the formula, you are not going to know it. What's the formula for S again, class?
S equals theta rad.
S does not equal theta rad. Theta rad equals theta rad. What does S
R.
equal? R theta rad. All right, what's V?
R theta rad.
Or?
S over t.
Or?
R omega.
R omega. And what does omega equal?
Theta rad.
Theta rad over t.
Theta rad over T. Okay? Using those formulas. 45 to 67, the odd. So let's do every other odd. So let's just do the other in pairs. Do the first odd in every section. So 45, 49, 53, 57, 61, 65. Every other odd.
Did you guys get 2.01 for the first answer? time required?
Find time.
Yes, it is.
You know, that's why I'm here, to help things make sense. Just a couple more minutes to be finishing up those every other odds. First problem in each section. If you happen to finish early, go back and do the odds you skipped. And I'll go over those answers as well. Finish all the alternate evens or alternate odds as well? Wow, good. You just sit there bored then for a minute.
By alternate, you mean like 47, 50?
Right, yeah, the ones we...
I thought you meant like the 45, 49, 50.
Right, so do those first, and then I said if you finish early,
Okay.
go back and
Right.
work on those. See how many of those you can get done in the 1 minute you have left. Finish all of them? Oh, good. All right, I'm going to put your pencils down. Let's take a look at these together. And number 45, what did you get for the angular velocity, Quentin?
2.01.
Good, 2.01. Per second. Radians per second, or just per second. Number 47, if you made it that far, would have been 0.142 per second. Number 49, what did you get, Jamie?
154 meters per second.
Good, 154 meters per second. Number 51, if you made it that far, would have initially been 3,069-ish centimeters per second. Rounded 3 sig figs and changed to meters, 30.7 meters per second if you made it to 51.
Can you work one of those out?
Number 49? Yeah, linear velocity.
I did the wrong.
Yeah, have to use the correct equation. They're just plugging the numbers. Number 53, finding the angular velocity. Chris?
I have 3.56.
Good, 3.56 radians per second, or just per second. And then if you got to 55, it's 0.082 per second. Number 57, Ethan.
I had 82 seconds.
Well, that time would be seconds. It's just 82.
Okay.
82 radians if you want to go there. Just
I was
82.
confused. I was like, I didn't know what goes after.
Yeah, theta rad is radians. Theta rad radians, or just leave it empty. 82. If you happen to get to 59, it's 4,760.
You use you're supposed to use the omega equals theta right over t for that, right?
No, you're finding theta, you've given t, and you're given omega. So you need an equation with omega, theta, and t in it. That's this one.
Yeah, that's the one I said.
You said theta rad over.
Oh,
I think maybe, yeah. Omega equals theta rad over t. There, yeah. So where you just multiply these two to get the theta rad. Number 61, finding time. So you're going to alternate theta rad over omega. And let's go back to Quentin. What'd you get on 61?
0.333 per second.
Right, 0.333 repeating. Well, let's make that a fraction. What is 0.3 repeating? 1/3. 1/3 seconds. And you kind of have to do that because you have no sig figs, or 0.3 repeating seconds, because you can't round to sig figs. Everything's exact. Number 63, if you happen to make it that far, 0.099 seconds. And number 65, Jamie.
0.098 per second.
Good, 0.098 per second, or radians per second. And if you happen to make it to 67, that's 2.4 per second. Questions on these?
Only two, I guess, were the ones that I asked for the equations for.
So if you know the equation, you're going to be good. But you have to know the equations. Right? Right. Those equations.
So in every instance, can you always use V equals RW instead of having to do V equals R theta right over T?
Only if you happen to already know omega. Right? If you're given omega, use this. If you're given a theta rad and a t, I mean, I guess you could find omega first and then do that. I just look at it, there's 1, 2, 3, 4, 5 equations to know. You know those 5, you good. Questions?
I don't know this, I'm not good.
That's bad.
What is
Clear your desk. Clear your desk except for a sheet of paper, and a pencil, and a calculator. But you feast your eyes upon the equations for one more moment. Say them with me as I erase them from the bottom, class. Omega equals theta rad over t. V equals R omega. V equals S over T. V equals R theta rad over T. S equals R theta rad. First last name at the top of your paper along with today's date. Today is, it's not August like the calendar says, it is now September. September 10th. 9/10/21, today's date. 9/10/21, today's date. By the way, we will be ending the video here, so if you're watching on YouTube, the description of the video has a link to the SAT prep that they'll be doing for homework tonight.
I'll check my book down.
Yeah, clear your desk except for a sheet of paper, pencil, and calculator, I believe is what I said. All right. Let's take a look at the quiz together very quickly. Numbers 1 through 5. You're literally just writing out the formulas. But use the formula that I'm specifying here. 6, 7, and 8. Solve for what I'm asking for. Now notice number 8 uses what was given in number 7. Okay? And then number 9, a word problem for you to solve. All right, you may begin.